Hi everyone, good morning or good afternoon, depends on the time zone that you are located in. This is a very unique opportunity to present in this workshop, and in some way it saddens me that I can't do this in person, but I hope the recording would help to share some information, and I would love to hear from you later on. My email and other contact information are available in a final slide, so please feel free to reach me. But we are going to start talking about the concept of leveraging the research linked data and persistent identifier for building the strategic partnerships in universities. This is based on the work that currently we are doing in the Swinburne University of Technology. That's where my group is located in Australia. Also, I have borrowed some ideas and slides from the recent presentation that we had in the Research Data Alliance plenary in Brisbane, Australia. So kind of this talk combines two different elements: our experience and projects in Australia, and also reflecting on a conversation that we had in the Research Data Alliance. On that introduction, let's start. So my group is located in the School of Business of Swinburne University, and one of the activities that we recently start looking into is mapping the partnership of our school and also entire university across different government agencies, the different businesses, the small to medium businesses, large corporations, sport clubs, and not-for-profit organizations. So basically the idea is that to understand how our group, how the school, and how the entire university work with different sectors, and where is our collaboration network. So to get the information like this, we had a special or specific focus area. We were looking for specific domains. We wanted to know where are the work or effort or what researchers or partnerships we have in the area of the sustainable innovation, about the climate resilience, about tackling the bullying in the sport, decarbonization, community well-being. So there was a specific focus areas, and in almost we were aiming to map our partnership across different focus areas. Now, in the activity like this, usually in the research environment, we look at the research outputs as one of the metrics of matching the research capability to the actual partnerships. So two main sources of information that we can use. One of them is publications, and another one is research projects and grants. Both of them tells a very good narrative about our research activities and research capabilities. Now, if you have the information for both of those, these days leveraging the retrieval augmented generation loops plus the large language models together, with feeding some taxonomy, it can give you a very good mapping. And there's a lot of literature in this space, so I won't go into the detail of the technicality of doing this. This is now 2 or 3 years down the track after creation of the transformer technology. It is quite a well-established exercise. Usually in this kind of technology curves, in the beginning we're dealing with the algorithms to optimize them to make them work, but then later on down the track when we apply those, the biggest problem that we have is that to make these techniques practical, we would need the information underneath. So in this case, publications and projects, the informations that are feeding into these pipelines are the main problem. So well, we can in many schools, and our university is the same, publications are kind of accessible. So we have access to the open access repositories, we have access to almost all the publications that university publishes, and that kind of solves some of the problems here. But projects, they're not. Projects are quite complicated to get access to. There's a lot of privacy concerns, and also there is no proper repository of having all the projects for the university. So looking at just at the publication side, we have previously done this in prior years. We looked at the entire publication cohort for Swinburne. We have mapped those to another sort of taxonomy. We were looking at mapping the university research outputs to sustainable development goals from UN, and the result of that published in Array Journal Publishing it is a well exercised process and quite a reproducible result. However, when we get to the projects, things get more difficult. So in this case, I have the screenshots from the basically profile page of Swimlearn. This is a platform that basically runs based on symplectic elements, and it has a nice list of research outputs and projects. Now, when we get to the projects in this space, we have a project name, we have the funder, we have time frame, we have the even investigators, but oddly enough is only limited to Swinburne University, and we are missing some critical information. We don't have description, we do not have a list of external investigators. This potentially is a data gap in our system, but also we are missing the collaborative organizations. Now, further investigation underneath of this, we realize that there is a lot of information gap inside the open space of the presentation of these projects in each university, and then in a higher degree when we connect this information, if we connect them to ORCID, the same kind of information gap would ripple effect into those open access ecosystem. So there are missing gaps across the board when we basically look at the open data. Now, what can we do? So the biggest question that we got here to answer those is that for large language models to work, in order to make those mapping, where can we get the missing pieces? So there has been a significant investment in the data infrastructure that connects scholarly works together. We had in early 2000, we had Serif or Euroserif, and after that, in the following years, from 2010, we almost had a project after project after project. We had Microsoft Academic Graph, we had Scholix and Research Graph, comes out of Research Data Alliance. We had SciGraph, we have OpenAir Graph, we have GACE's Knowledge Graph, TIB Knowledge Graph, OpenAlex, and finally in Australia in 2023, we have the Research Link Australia by Australian Research Data Common. So all of these platforms at the core, they are trying to connect the scholarly networks together in order to provide this kind of discovery capability, in order to find out where and how we can trace the digital footprint of research, find the collaborators, find the experts. So in Australia, the Research Link Australia was focused predominantly on the research industry collaboration, and this was triggered by government initiatives and investment in this space to make the research more applied and foster that research industry collaboration in the sector. Now, it has a round of consultations working with different stakeholders. It tries to address the questions from the perspective of different groups or different perspectives, from point of view of researchers who try to find the industry partner in the research, from the point of view of the industry and companies that they try to find the research expertise. We had the policymakers in this conversation who they want to know the national research capabilities of Australia, and then we have the facilitators in between that they try to connect the dots. So there are lots of stakeholders in this ecosystem, and that's motivated the Australian government to have the national level infrastructure for kind of creating our own Australian research knowledge graph or Australian research graph. Now, there is a portal now in front of this system that provides access to the wealth of information, and the underlying data ecosystem of this is connections between the persistent identifiers. So it connects the ORCID records from Australian researchers and our collaborators to the organizations that are identified by the number of different persistent identifiers, connect them to the publications, and then link them to the grants and funding. Now, the majority of information provided in the funding ground here is either information come from the competitive national grants that they have publicly published, and they have accessible information with a very good metadata, or we have information from the ORCID that also includes a lot of funding information. Now, ARDC is in the process of ingesting lots of other sources of information into this, but that is one of the focus area that also in this talk we are referring to that as one of our major problems. Now, the infrastructure that connects the dots for these systems is a national persistent identifier graph that reads the information from different sources, creates a graph out of this, and then they optimize the graph by looking at the Australian ecosystem. For example, for companies, we are linking this information to the Australian business numbers, so we know exactly what companies they are and how they are operating in Australia. That provides a context around the nature of the collaboration, and then the outcome of this across the network for the national PID graph, it is holding in Neo4j. So the Research Data Australia project have used the national PID graph in the beginning, and still is one of the core components of this. Now, moving into the actual capability available is that once you look at the portal, the front interface of this one, is that you can see information about the grants that are publicly funded. You can see the information about the researchers and about organizations. So for a given project, like this is one of my own projects, so I thought that's probably a good example. We can see this is funded by Australian Research Council, and then we can see there's a list of researchers with their ORCID that connects to this project. And on the right side, I have a screenshot of the related organizations who are participating in this project. Now, the problem here is that that level of the granularity of information doesn't exist when the project or grant is not funded through the government major initiatives. Usually, we would end up with a very narrow metadata, as we saw before with other projects on the Swinburne page. It would end up to be just probably a title and very brief information about the funding organization. So that would leave us with basically the next piece of kind of puzzle here. And what about the other projects? Like, how do we get the information about other projects? So in a lot of universities, the information about the contract research, philanthropy fundings, and a lot of non-competitive grants, they are still available in the form of the research contracts and other internal forms. So in this case, in Swinburne University, we have a form that's called SR1, and that one has most information that we were looking for. It has a collaborators, it has a list of partner organizations, it has a project description. It basically provides a lot of metadata that would help us to understand the digital footprint of research and a plan, and it is a wealth of information for knowledge mining. So now we also need to recognize that because of the confidentiality, this information is not publicly available. That means from this point, basically, I can work with the Swinburne records to create a, if you like, Swinburne research capability map, but I would not be able to do the same exercise across other universities. So if we just narrow down the scope only to Swinburne, we can build the pipelines that extract this information out of different sources. Like what we have here on the screen is a pipeline classification runs top of the N8N that's been run top of the high performance computing. And we have implemented this to classify a lot of legal and patent documents internally at Swinburne. So this have access to the confidential information and then extract the information that are basically reusable for that research capability mapping. Now, the biggest problem that we would have at a larger scale is that this exercise, unfortunately, is not reproducible across multiple organizations, not because of a technical problem, but because of a legal problem. The confidentiality of this information stops universities to sharing that level of detail, and that is one of the drawbacks in this space. Now, I'm going to now go to another kind of a chapter of this conversation, and this is about AI and what the generative AI tools knows about these research activities. So at the moment, there are a lot of AI platforms like the GPT, Gemini, Copilot are out there, and we are starting to see some changes in the market. So this inherently brings the question, that how much these models and tools knows about our projects. So there has been a shift in the consuming use or consumers' approach toward information. So just use of chatbots went from the 3.1 billion to 7 billion monthly visits from April to March 2024 to 2025. However, that is very tiny compared to the search engine use, which goes from 149 billion visits to the 163 billion. So although chatbots are growing, but still there is a huge gap in this space. So there is a cultural shift is happening at the moment. I'm not sure how far we would be to the point that say significant of traffic has been shifted to the chatbots, but one of the products of this transition is that the AI platforms, probably that would be a better term than just call them chatbots, the AI platforms start to ingest a lot of information from different sources in order to make these intelligent bots more responsive to the queries that user provide. So with the light of that question, I have started to testing this, and I just created a very basic simple prompt that provide a concise and accurate summary of the research expertise, focus areas, and academic background of Amir Aryani from Swinburne University, include the research domains, notable projects, and area of impact. And then I tested these against different AI models to see what do we get. So the first test is against the GPT. It have identified a number of sources that it has used. So you have ingested data from ORCID, as you see on the right. You have imported data from ACM libraries, from Swinburne pages, from even Cyrus, which is one of the projects, one of the centers, and I'm a node leader on that one, even from information from the RMIT University when I did my PhD. Now, evaluating the content provided here is that academic background is correct, expertise and research focus area is actually very accurate, the leadership roles and applied programs are all correct. However, it's very limited. It does not have that extensive list of projects and impact items. Although, just acknowledging this, you can prompt this to get in more and more detailed information, but still there are limitations in how much this platform provides. Now we go to Gemini. Gemini also have a similar kind of output. We have the research focus area, we have the academic background, we have the sources. All the sources here, interestingly, are more limited. It basically goes to 3 different sources, and is also not very impressive. So I would assume that Gemini, given access to the Google search engine, would provide a better result. Although there is a caveat here, you can do a deep search on Gemini that would provide a substantial document. Now, the other platform I tried is Cloud. So that, again, the same timeline, but this one have a very specific list of sources. It even includes LinkedIn. So these models now go around and get the information from all different places that they can find. And that's actually bring back to that conversation of missing different pieces. A project that we may not have information about this in one source might have another article written about that in another source. I remember when I was looking at this exercise, I found one of them looked at a webinar that I gave a while back ago, and the content of that was available on another website. So that also ingested those materials. But the most interesting one was Copilot. So just emphasize that this is a Copilot enterprise license. So this one have access to my SharePoint, and it is a Swinburne license of Copilot, so it has access to a lot of background information from the ecosystem of Microsoft, but it's quite extensive. So it gives a reasonably well-crafted overview with the number of grants, citations, projects. Although interesting enough, the grants are limited to the publicly accessible information. It only shows only 6, which in contrast, I have about 20 grants listed on my Swinburne profile. It provides research expertise and focus area, much more detailed with proper sources and citations. It has even major research initiatives. It provides a timeline of research that was quite interesting. And it provides the major projects, but all of these projects are the ones that are publicly accessible. The system even provided almost a collaboration and impact statement with quite usable information. It has information about the social impact, the scholarly impact, capacity building. So it is a very good summary. However, across all the information provided here and also what we got from the Gemini and ChatGPT and Cloud, we didn't have any information about the private projects. So what it means is that the initial question that we had about where are the missing information about the contract research projects still is not available to any of these ecosystems of large language models. However, these models are quite useful for completing the metadata. These are almost ingesting information from lots of different sources, and it can help us to build quite an accurate picture of research. And that would leave us with kind of one final question. How vital are the role of these PID graphs to ensure that the LLM data have accuracy? Basically, large language models, in a lot of examples that we saw, use ORCID as one of the sources. They also use the DOIs and other persistent identifier networks. So accuracy of the persistent identifier metadata seems at this stage is directly correlated with the functions of these large language models. So on that note, I hope you found this information useful. I'm really looking forward to hearing from you. So if there is any questions, if you want to open up this conversation, or you see there are potential collaboration opportunities, please feel free to reach me on the email on the screen. And also there is a LinkedIn account that with a QR code that you can ping me on that directly. So I'm very much looking forward to hearing from you. And also in advance, I hope you all have a very, very good holiday. And hope you have a wonderful Christmas, and hopefully see you in 2026.